Fine, guys, let's start. Fine. Uh, so yesterday we have seen different type of plots in Matplotlib, right? So we have started with scatter plots, agree? And then we have seen what else? Bar plot, bar graph, histogram, okay? And simple line, fine, pie chart, etc. Fine. So today we are going to see few more example or different ways of plotting the similar graphs in the Matplotlib. Okay, so a bit easy type of plots and some more different functions in the Matplotlib. Okay, so let's do that quickly. And but before that, I remember yesterday at the end of the session, we are trying to actually save a particular graph and we were facing some issue, right? So it was actually simple. The thing over here is, for example, if I show you, yeah. So when you want to save any graph over here, okay, the thing you need to do over here is you need to put it in the same part of code because the yesterday what we are doing over here is, for example, I'm doing this. Okay, so what I'm doing, I'm plotting this histogram. Okay, now once I do that, so it is this is done, and after that if I try to save it, okay, after that if I try to save it, the bar graph, okay, so over here if you see, fine, so it's not saving because the plt, the graph is not present in the plt now because it has already printed. Okay, but if you do it this way, okay, so once when you're generating and immediately when you are saving it into some graph, some figure using the same plt object, okay, now when I do this, okay, so now when I go over here, you can see the graph. Okay, so it's a learning for me also. So just remember, before you actually, what the point here is, before you show, okay, so because see the way how it works is, I think, see, I'll show you. See, I'll do this plt dot show. Okay, now when I do this, it will not be present. Okay, why? Because you are using the plt object, okay, from the matplotlib, fine. So plt module, yeah. So using that you are generating, okay, 1 second, Sirisha is yeah. So you are using the plt, okay. So now in the using this plt you have generated the image, okay, and after that you have shown the image, okay, now it's done. The image is no more up, no more available with the matplotlib because it has already shown. Okay, now when you save it, a empty image will be saved. Okay, so you need to use, if at all you want to use show, you need to use the save image, okay, before the show. Okay, you need to use the save image before the show. Okay, then you can see the image. Okay, but else if you don't want to use the show, then that's also fine. Okay, in particularly in Jupyter Notebook, if you don't want to use the show also, it will just give the output. Okay, but in other IDs, okay, or in practical purpose, if you want to see the output, so you need to definitely, okay, uh do plot plt dot show. Okay, but just remember, if at all you are trying to save the image, you need to do that before you show it. Okay, because once you show it, it will not be able to save. Okay, so over here, so I'm not showing it. Okay, so I'm just generating the output and I'm saving it. Okay, so now when I go over here, when I see the graph, so it will be present. Clear? Huh? So for example, even this also. Okay, so over here also, I'm just saving it in pie graph. Okay, so now if I go over here, you can see the graph. Okay, Is it clear, guys?
Yeah, Santosh.
Okay, fine. So this is how you can save the any image. Okay, pl.selfie. Fine. So now let's jump into topic of today. So few more functions from the matplotlib. Okay, fine. So see guys, I'm taking the example of iris dataset. Okay, so today's class is going to be also simple, just like yesterday. Okay, but you are going to see many different sort of things. Okay, see. So I think you are very much familiar with the iris dataset. We have seen this a lot in the statistics module. Okay, so you know it will be having sepal length, sepal width, petal width. Agree? And the species. That means what is the type of the flower. Okay, fine. So what I'm doing over here is, so I'm just replacing the category Setosa, Virginica, or versicolor into numerical values. How I'm going to do that? Fine. So I am replacing the species column with the same column, but dot replace. I'm saying Setosa 0, versicolor 1, Virginica 2. Okay. So I'm just replacing these categories, assigning a value, numerical value to each of this category. Okay. So now once you see that, once you see after this, you see in the place of Virginica, you have certain value, or let me run this again for better. Okay. Oh, see, the reason why it is not matching over here is because if you observe, I'm using sample. Okay. So randomly it will generate some sample. So that's why here it is picking up some 51st record, and here it is taking 43 record. Okay. So that should not be the case. Okay. Let me change it to head for a better representation. Okay. So now if you see, we are having Setosa, all Setosas are 0. Okay. Getting? So similarly, after that, you will have versicolor as 1 and virginica as 2. Okay. Okay. The reason I think I have used sample was to show you that there are three different type of varieties. Okay. Because over here, usually in iris dataset, what happens is the first 50 records will be Setosa, next 50 will be versicolor, last will be virginica. Okay. It will be like that. Okay. So that's why when you do sample, you can at least see there are actually three different type of what varieties. Okay. Fine. So now next thing is, now we got the all the varieties got replaced into numerical values. Okay. So now see, um, fine. So I'm replacing the column names. Okay. So as sepal length will be sepal length in centimeters, petal length, sorry, petal length, sepal width, petal width. Okay. Fine. So after that, if you observe, see what I'm doing is, yesterday we have seen scatter plot, simple scatter plot, but here if you see what we are doing, it is, so I'm doing scatter plot, okay, between iris sepal length and petal length. Okay, now c equal to iris of species. Okay, and c map equal to z and alpha equal to 0.7. Okay, so I think you are aware of this and also this. Okay, but these things are new. Let's try to understand this. See, c of iris species, in the sense, what is c? C is just the, it's also called the color coding. Okay, so it's a color coding. C stands for. That means you are using the a particular column. What column you are using? Iris of species. Okay, this column we are using, okay, as a color code, to color code. Why? Because to differentiate the three types of flowers with colors, so that it will be very much easy to identify. Okay, so that's why we have converted the species column from categorical Setosa, versicolor, virginica to 0, 1, 2. Okay, so that we can use it as a color code. So now what happened when I use iris as C equal to, C stands for color code. Okay, so iris of species. So over here, this part is a color coding. Okay, this is a color coding. Okay, this is getting built using which column? Iris species column. And what are the values of species column? It is 0, 1, 2. Agree? Setosa, versicle, Virginica. Fine. So using this, I'm applying to the color coding. So that's why if you see, it is starting from 0 all the way to 2. Okay. Now it is giving colors also. So 0 will be like some sort of colors it has given. So to differentiate between different values. Okay. So now what we are doing here is we are plotting. See, each data point over here, whatever you are seeing, right? Each data point is plotted with two values. What are those two values? X and Y. Okay. Sepal length and petal length. Using sepal length and petal length, a dot is plotted on this graph. Okay. It is plotted. But the color is coming from this iris of species. Okay. The color is coming from iris of species. That means what? So it has assigned one color to each of the category. Okay. For example, it has assigned some blue to Setosa, some this light green to versicolor, and this brown to Virginica. Okay. So the color coding is coming from this species column. Okay. And CMAP is just a type, I would say the type of color coding which you want to use. Okay. So here you're having blue, light blue, right? So you can also, there is no rule that it should be only these colors. Okay. So you can have different sort of colors over here. Okay. It could be in the shade of green, in the shade of blue, in the shade of gray, black, all. So those varieties you can get it from the CMAP column. Sorry, CMAP parameter. Okay. Which we are going to see. Okay. And alpha is just the transparency and opaqueness. That means how dark or how light these should be. Okay, that will be decided by alpha. Okay, just the designing and formatting parts, the CMAP and alpha. Okay, but the main thing here is what data point you are plotting and what column you are using for the color code. Okay, so over here you can clearly, by looking at it, you can understand all these three are pretty much well separated. Okay, all these three are pretty much well separated. So you can see you got a bunch of values. Okay, let's say this is Setosa. You got bunch of values, Setosa, completely separated from other. And how we can just, if at all you want to find out only Setosa, filter out only Setosa. If you remember, we have done it in the in the statistics also, right? So you can just say petal length is less than let's say this is 2.5. Okay, so 2.5. If I just say petal length on the data set, if I filter it on simple condition called as petal length column, petal length is less than 2.5. If I do, only these will be extracted, because for other type of other varieties, obviously the petal length is greater than 2.5. Okay, so if I say greater than 2.5, obviously I will get this and this also. Versicolor and Virginica will also be extracted. Okay, but at least with one single column, okay, with one single petal length, if I just put a condition 2.5, out of 3, I'm able to completely separate one type and remaining 2 into another bucket. Okay, that's fine. We will take care of this. But at least with one single step, we are able to segregate one type of flower. Are you guys following? Are you guys with me?
Yes, sir.
Yes. Okay. So if you remember, we have done this in the statistics class also. Okay. So I'm not sure if I could quickly find it. Oh, okay. In the notebook, in one particular code example, I was showing you how you can I think using the KDE plot. Okay. So in the probability distribution. Okay, not in this text part, but in one of the notebook, I'm pretty much sure we have seen the example that using one particular parameter, we are able to clearly separate in one column. Okay, so that was using statistical functions like KDE plot, okay, kernel density estimation, okay, and before that there was also one other plot, I think probability distributions, okay, yeah. But here you are going to achieve the same using simple plotting, okay, fine. So see what we're going to achieve here, guys. Ultimately, what is the concept over here? If at all given, see, from if I want to speak from the machine learning point of view, my objective is, if someone gives me these measures, if they just give me four values called as sepal length, sepal width, petal width, okay, I should be able to tell them what type of flower it is. That's my goal. Okay, you will see this as a machine learning use case when we are learning machine learning problem. Okay, but the problem which we are trying to solve over here is, given the input, you should be able to predict the output. Fine, simple. Yesterday also I was saying in ML, what is the main point? Given input, predict the output. Okay. Now what is the input over here? Input will be this four values: length, sepal, petal, sepal, petal. Okay. Output will be what? This one of these three categories, flowers. Okay. To do that. So before going in using any model, okay, before going into any model, just by visualizing, we are able to clearly segregate one type of flower. Okay, so that is, I would say, one of the advantage of visualizing. Okay, so if it is not with the visualization, it will be very difficult just by looking at the Excel sheet to understand that you can achieve this, right? But using visualization, as I said earlier, so we can understand pictures very much better way than some text, right? So just by looking, you can clearly see this is very easily separable. Okay, so that's regarding the usefulness of this plot. But coming back, you are plotting X and Y. Okay, C is the color coding which you want to use, and CMAP is a type of color coding, and alpha is 0.7. Okay, so there are different ways, different options over here. CMAP. Okay, something I remember. Let me first run this and see. Okay, so what happened? Mm. Mm. Okay, so now in place of jet, I think we have something called as Viridis. Okay, we have something called as summer. Yeah, so, see, everything will be same, only the color codings will be different, guys. Okay, so in the CMAP, the color coding options, okay, you have something called as summer, so it will use these colors. Okay, the plotting, everything will be same. And also I think we have winter. Okay, winter is using some other colors. Okay, so I think, yeah, color maps, CMAPs is color maps. Okay, so you have Viridis. Okay, Viridis is one of the, so as you can see, there are so many options. Okay, so if you use Viridis, it will use this color code. Okay, see, okay, and you have so many codes over here. Okay, see, you have summer, you have winter, you have autumn. See, cool, there is also something called as cool. Okay, fine, this looks great, this color. Okay, fine. So after that, alpha is just the transparency, as I've shown you. So if I do alpha equal to 1, so they are more thick. Okay, I'm not sure if you're able to see the difference. See, it became very thick. Okay, for example, I will just show you the very 0.1. Okay, see, it's very light. You're able to see, so it's just a transparency. Okay, so if I use, I would say if I use 2, can I use 2? No, because it's supporting only 0 to 1. Okay, fine. So if let me use 0.9 something. Okay, so it's the thickness of these colors. Okay, fine. So that's how you can plot a scatter plot. Is this example clear, guys? Let me know. Just let me know if you're having any questions. Okay, because this is the actual usual way which we do the scatter plot. Because yesterday what we have seen simple plotting is that's a basic scatter plot. Okay, so what we have seen, yeah. So yeah, so this type of plotting is basic scatter plot, but practically we do this. Okay, so we also use color coding, type of color coding alpha. Okay, this is a full length code of scatter. Is this clear, everyone? Any doubts? Clear? Okay. So I would say you experiment with different columns. Okay. For example, I don't want sepal length. I'll go for sepal width. Okay. Okay. Fine. So I'll use sepal width and sepal length, both sepal only. Okay. This is not that much helpful. Okay. So then I'll go for sepal width and petal length. Okay. So this is looks like these are getting separated over here. Okay, you can put a filter of 0 greater than 0 less than 2. Okay, some insights you can definitely find out. Okay, so and visualization will be helpful, and it is one of the mandatory steps, guys. Okay, whenever you are working on the actual data set, okay, or any small projects also, visualization will be very, very important. Okay, instead of directly jumping into the model training. Okay, fine. After that, plot size. Okay, so everything is same, fine. So one basic thing is regarding the size of the plot, guys. Okay, so what should be the size of plot? Because if you see, the whole graph is not fitting to my screen. Okay, I need to scroll down a bit. If I scroll down, I'm losing the upper part. Okay, so that can be controlled, okay, using this fixed size. Okay, from plt.figure. Okay, just reminding you, we are still in the matplotlib. So whatever we are doing is still using matplotlib, that using the plt. Okay, so wherever we are using the plt, it is regarding the matplotlib only. Okay, so we did not start the seaborn yet. Okay, just if you are getting confused. Okay, so from plt.figure, so you have fixed size, figure size. Okay, so it is 8 by 8. Okay, so when I run this, okay, so I'm not able to see the whole graph. Okay, so let me do this. Okay, 5 by 5. It is just row, it is length and breadth. That's it. Okay, yeah, this is better. Okay, 5 by 5. I can see the whole graph in one screen. Okay, simple figure size. Okay, so I hope that's clear. After that, we'll see certain annotations. Okay, I'm using this sample df batsman dataset, which we have used yesterday. Batsman runs average and strike rate. Now it is a bit more interesting. Okay, see, this graph is interesting. So what I'm going to do over here is I'm going to plot a scatter plot, okay, of this data set. Okay, and you are aware that when I do scatter plot, we have this. Okay, along with that, I also want to vary the size of this dot or this plot. I would say dot. Okay, vary this dot based upon particular column. Okay, I want to relate this particular the size of this dot based on some column. Okay, and also attach a text to this column, text to this dot. Getting? I think we have done something similar yesterday. Okay, so if you remember, yeah, if you see, the size of these dots is different. Okay, so earlier this is a simple scatter plot where every dot is same size, but later we have also used this parameter called as s, which is size. Okay, so where we are able to attach the or to say the significance of this particular column called as runs. Okay, based upon this runs column, we are varying the size of this dot. Okay, I hope you remember it from yesterday class. Now, but what is this dot? If I ask you what does this dot represent, you don't know. What is this dot represent? You don't know. What is this? You don't know, right? So now we are going one step ahead and we are also attaching the name to the dot. Okay, so now see. So the first thing is, before going this, so okay, how to attach the name. So we'll see a simple example and we will come back. Okay, so that we'll able to understand it in better way. So to attach a name, it is very simple. You need to use something called as plt.text, guys. Okay, so over here, what I'm doing, a simple example of x equal to 1, 2, 3, 4, y equal to 5, 6, 7, 8. Okay, I'm plotting plt.scatterplot x and y. Okay, till here it's very simple. You are just plotting. It will consider 1, 5. It will plot 2, 6, 3, 7, 4, 8. It will be plotting. Okay, but now to attach the name, you need to use plt.text. Okay, for 1, 5, I want to use a name called as 0.1. Fine. So wherever it's plotting 1, 5, okay, so here it is 1 on x-axis, 5 on y-axis. So this is a 1, 5 point. Okay, but I want to attach the name called as 0.1. Okay, 2, 6.2, 3, 7.3, okay, 4, 8.4. Okay, using plt.text, right? So you can add the text. Okay, and also obviously you have, since you are adding a new parameter, you can also control. So by this time, I think you might have already understood that every new thing we are using, you also have the options to control that. Okay, so because we can control the dot size, okay, we can control the dot color. Fine. Similarly, we can control the size of this plot. Now similarly, since we are using this text, we can also control the size of the text and also color of the text. Simple. Size is 12, brown, color brown. Okay, so fine. So if I go for, let's say, only 10 and some, let's say, red, what it's giving me. Okay, red color and size 10. Okay, so fine. Now after that, this is how you can add the text. Okay, I hope that's clear. Now using the same example over here, what I'm doing here is, see, I'm just looping through this data frame. Okay, see, first of all, what I'm doing here is, for plt.scatter, first we are plotting the graph. Initially in the line number 1, we are fixing the size. Okay, figure size 1810. Okay, length and breadth. Fine. Next, we are plotting using two columns. What is this? Average and strike rate. Okay, and the size of this bubble, I am assigning it to the runs. Okay, based upon the runs, similar to yesterday's example. So I'm plotting with average and strike rate. Okay, this will be x and y, and size of the bubble is determined by this runs column. That means if the runs are less, the small bubble. If the runs are a bit high, like 4K, it will be a bit big bubble. Okay, and if the runs is very small, 831, it will be still smaller bubble. Okay, so now this is a graph. Using that, these dots are created. Okay, but the names are not yet created. Okay, names are not yet created. How we are going to attach the names? Very simple. So just like how you have done plt.text, okay, and you have said what values, to which value you are plotting, and what is the text that should be attached. The same thing we are doing, but in the loop format. That's it. Okay, what we are doing for the in range of sample shape of 0. What is the shape of 0? If you have noticed, we are using in many places shape of 0. When you do shape of 0, it will get the complete length of rows. Okay, for each and every row we need to do, right? So shape of 0 will give you what? Length comma rows comma columns, and in that will be a tuple, and in that 0th element will be number of rows. Okay, and that number of rows, when you do range, so it will give it in the 0 to this -1. Okay, range function we are familiar by now. Okay, so now for I in range of this, we are iterating to that, and plt.text you're using. Okay, and what we are doing, see, which values you want to plot. I'm just use this, okay, for you to get a clear understanding. Okay, you need to specify 3 things. One is x value, y value, and the text value. Simple. So here also there are just 3 things. This is one value. Okay, so don't get confused. Okay, this is one value, this is another value, and this is another value. Okay, so this is what? The same thing, the average what we are plotting, strike rate what we are plotting. Okay, and we are doing average dot values of I. Okay, that means it is taking one value at a time, guys. Simple. So when we are looping through I in range of this whole sample df dot shape of 0, that means each and every row it will loop, right? Same thing, you are taking one at a time. Okay, so I'll just show you what does this sample average values of 0 I represents. Okay, I in the sense it will be 0 1 2 3 4, right? So if you see here, see, sample df average dot values 0 means it will take the first value from average, that's it. Okay, so what is average? So if I just do batters dot head, okay, the average value, okay, we are plotting it on the sample, right? So sorry, so we are not plotting it on the whole batters data set. Okay, so we are plotting it on just the sample df. Okay, what did we use? Okay, we had to use the sample df. Okay, then we need to use this. So in this sample df, what is the first value of average? 22, and first, what is the first value of strike rate? 132. Okay, so when I do this for the strike rate, okay, when I do this for the strike rate, I got 132. Fine. So see, try to understand, when it is plotting this, when it is doing PLT dot scatter, it is taking the same way. It is just considering one value from average, one value from strike rate. That means 22, 132, it is plotting. Okay, and 39, 130, it is plotting. 39, 120, it is plotting. Okay, it is doing when I do scatter dot plot. Okay, now when I try to add the text, right? When I try to add the text, I am accessing the same values. Okay, using the column dot values parameter. Okay, why? Because when I do, if I just do average, okay, if I just do average, it will give me all the columns, all the values. Okay, but I don't want all the values. I want one value at a time. Why? Because this is the way how I need to mention the text values into the text. I need to just mention what value from X I need to take, what value from Y I need to take, and what is the text I need to attach. Okay, so that's why I don't want this whole thing. I just want value of 0, that means first value. Similarly, value of 0 over here. Okay, first value. So 22, 132 will be the first set of values. Okay, so over here when I equal to, it's looping over here, what will the first value of I? 0. So this will be 0, this will be 0. Okay, so sample average value dot 0, that means this one, and sample df strike rate of 0, that means this one. Okay, so 22.1, 132. Okay, wherever it is plotting 22, 132, okay, there I need to attach what? This text. Now what is this text? This text is also, let me print it out. Okay, so now this is also the first time it will be 0. Okay, so what is the name? KH Pandya. Okay, the first one is KH Pandya. Okay, so over here for the very first time, okay, so for the very first time when it is plotting, the values will be 0, I will be 0. So this X and Y will be plotted. Okay, this will be X and Y. Okay, and the name will be KH Pandya. Okay, KH Pandya will be attached to that bubble. Okay, similarly, the second, see, the plotting is done. For plotting, we don't need to specify. So it will automatically take one value from X and Y. It will plot all the bubbles. To attach the text, we need to loop through each and every row and attach the name. What will the second time? First let's, are we good, guys? Am I going too fast? Are we good till this point? Let me know.
Yes, sir.
Are you guys following really? Karthik? Okay, fine. So KH Pandya is attached to this first bubble. Okay, so now what is this? 22, 132. So wherever you have 22, 132, okay, so there the name will be KH Pandya. Okay, so now let's see that. So I need to find where is KH Pandya. Or else let's try to see what are the values. 22, 132, right? Why 22 is over here and 132 over here. Yeah, so see here, KH Pandya. You're able to see?
Yes, sir.
Okay. So similarly, for example, see this bubble is bit bigger, right? And for example, this is very, very small. I think this is still more smaller. See, ST Jayasuriya. Okay. So ST Jayasuriya, yeah. See, he has done only 768. I think that lowest is 831, but this is still 768. And I think from the sample, this is the lowest. Okay. So that's why it is a smallest bubble. How did we achieve it? Because we have mentioned the size should be taken from the sample runs. Okay. Based upon the sample runs, the size is mentioned and also the name is attached. Okay. So it has considered wherever it is plotting this, the name is attached over here. How did we attach? It is attached by sample of this one. Okay. So for example, if I just show you one more example of -1, okay, let me take the last example. Okay. So the last one is 31.1, right? Okay. So, and this is 121. Okay. And this is SSIR. Okay. So if I go -1 SSIR. Okay. So for SSIR, the values are 31, 121. Okay. But what are is runs? Okay. Runs are 2780. Okay. That I'm not plotting, but I'm using it for the size of the bubble. Okay. So now where is 31, 121? Here it is 31 and 121. Okay. This one, it got overlapped, but this is the SSIR. Okay. Fine. And I think the K Pollard, it looks like he has scored the highest. Okay. Where is K Pollard? This one? No, but actually Gautam Gambhir is 4217. Okay. Gautam Gambhir is a maximum. Okay. But where is Gautam Gambhir? Let me, yeah. Oh, this got overlapped actually. So this is a big one. Okay. Fine. Okay. So I hope it's clear like how you can plot simple two columns scatter plot and also determine the size of the bubble and also attach text to the bubble. Now using this image itself, we can clearly get some decent idea like what are the strike rate and average of every batsman and also what are his runs. Okay, fine. So I hope that's clear. Next thing is, yeah, so we have seen this. Okay, next thing is a simple addition to what we have seen now. Okay, the same thing, but only thing here is if you want to add some lines, okay, if you want to add some vertical and horizontal lines, you can achieve it by plt dot, see the same graph I'm doing, nothing new, but there are few lines. Okay, just for okay comparison. So if you want to here do we have any graphs? No. Okay, but if you want to have some comparison, like if you want to see some, what are the players whose strike rate is less than 130, okay, or whose average is greater than 30, fine. So it will be better view. If you have a line at 30, you can clearly see, you can clearly see there are all these players are greater than 30 average, fine. So all these players, you can clearly filter it. Okay. So for that, the lines will be very much helpful. So how you can achieve is very, very simple. So over here, if you see the PLT AXH, AX H line, what is H line? Horizontal line. Okay. And he's saying at 130, I want to plot a horizontal with a red color. Simple, very self-explanatory. So this is a horizontal line at 130. Done. And also at 140, I want to plot a green line, but a horizontal line, H line. Okay. Done. Again at 30, with red color, I want to plot a vertical line, V line. You observe V line. Okay. So over here at 30, we have a vertical red line. Okay. Clear?
Yes, sir.
Okay, cool. So simple scatter plots. Fine. So the next concept is actually an important concept called as subplots, guys. Okay, this is very important concept. What is the subplots is you are drawing graphs. Okay, from yesterday we have been seeing so many graphs. Okay, lot of graphs you see. Okay, but till now we have drawn only one graph. Fine, but what if we want to draw multiple graphs? What do I mean? In the same iris example, I was showing you, you can use multiple combinations, sepal length, sepal width, we can draw. Okay, petal length, sepal width, we can draw. Like that, you can have multiple combinations. Okay, instead of drawing each one of these in a single graph, it will be way more better if we have multiple graphs in a single graph. That means here I will do it for sepal length, sepal width. Okay, and here for other combination. Okay, here other combination, here other combination. Okay, so if I do all in one graph, it will be much more helpful, right? By looking at single graph only, we can understand which particular columns are more helpful than other columns. Okay, instead of having 4 different columns. Okay, so for that purpose, okay, we have the concept of subplots. Fine, we have the concept of subplots. Fine, let's see. So we have this data set called as BATAS. Same example over here. You are having, first if you plot BATAS average and strike rate, simple graph. Okay, BATAS average and strike rate is giving you something like this. Okay, and the title is something average, y is labeled strike rate. Okay, simple scatter plot which we have seen till now. But now okay, here we are just okay. So this we have already seen, but just I'm showing you the color and the marker we have seen yesterday, right? So the same graph, if you want to change, you can also add the color code to some color, and also marker also you can change it to different types of markers. Okay, and labels, X label, Y label, all this is fine. So I think now each and every line we can understand because we have seen. Okay, figure size we can control by this X, Y scatter plot, and color code and marker and title, X label, Y label, and show. Okay, so everything is cool. But now if you see here, there is one difference. Okay, till now we have used PLT. Okay, here and here there is a difference. Here I have used something called as PLT. Using PLT I have done all this, right? Observe here, PLT dot figure, PLT dot PLT, PLT, PLT dot show. Okay, because this is a direct plot, it's not a subplot. But over here I'm using subplots, PLT dot subplots. Okay, so when you're using subplots, it will give you, it will divide the graph into different boxes. Each one box can be used for a single plot. Okay, so over there in that scenario, you need to use AX. Okay, what is this? We are going to see. So you are having this, when once you do PLT dot subplots, it will give you two things. One is AX and figure. Okay, now AX, using this AX, okay, okay, you can create the graph. Okay, you can create the graph, and whatever you are doing earlier with PLT, now you need to use AX in that place. Okay, AX dot scatter plot, AX dot set label. Okay, and finally you can save it with the figure. Okay, but now this AX is very, very important. Okay, because we using this AX only, you can create subplots. Okay, how you are going to do that, we are going to see it in a moment. Okay, so this is a simple example. Okay, so you have created PLT dot subplots will give you two parameters, AX, and using that AX you do the same thing which you have done for the PLT. Okay, but if you want, but still it is only one single graph. Now coming to two graphs, now it is a bit more different. Okay, now see, I'm saying PLT dot subplots. In these subplots, observe here, I am using n rows and n columns. Okay, there are 2, 1. Okay, this is ShareX, just ignore this. Okay, so and figure is 10, 6. Fine, but observe this is very important. 2 rows and 1 column, that means 1 row, second row, first row, second row. Okay, and 1 column. Okay, this is row 1, row 2, C1. Okay, so that means you are doing what? You are creating two graphs, two subplots. Okay, notice here, 2 rows, 1 column means you are getting 2 graphs. Okay, so you are getting 2 graphs. When you get 2 graphs, okay, observe here, when you get 2 graphs, this will be graph 0, this will be graph 1. Okay, this will be graph 0, this will be graph 1, because 2 graphs by indexing. Are you guys following? Are you guys on track, or did we miss any points?
Following, sir.
Following? Okay. Yeah, if you're not following, feel free to stop me, Meghna, because a few new things. Okay, so till I've just shown you this will create subplots. Okay, but how subplots are created, we are going to see here. Okay, so in the subplots parameter, so we are mentioning the number of rows and number of columns. 2 rows, 1 column, that means 2 plots we are getting. Okay, now this plot you can access by saying index 0. Okay, that means what? Ax of 0, Ax of 0, okay, axis of 0 will be given to this first plot, and when you say Ax of 1 is for this graph. Okay, Ax of 0 is the first graph, Ax of 1 is the second graph. Okay, fine. So now when you want to draw something for this, you should use Ax of 0. So now I am saying Ax of 0, in the Ax of 0 plot scatter plot. Okay, and what I want to plot using batter average and batter strike rates and color equal to red. Okay, now this Ax of 1, this graph, use scatter plot and batters of average and batters of runs. I don't want color code, use the default color code. Okay, this is how you can access this Ax parameter, which will give you the subplots, and the indexing will be used over here. 0 is 1, this 1 is this graph. Okay, and now everything what you want to do for this graph, you should refer by Ax of 0. So I'm saying for Ax of 0, that means first plot, set title as this and Y label as this. Okay, there is no X label. I don't want to give X label. Okay, and for X of 1, this graph, I'm setting title, Y label, and also X label. Okay, so now if I go down, see, you can see clearly, this is Ax of 0. Okay, now this is Ax of 1. Okay, so for Ax of 0, you have only title and Y label. So this is my title, average versus strike rate and strike rate. Okay, but Ax of 1, I have title, X label, and Y label. See, my X is average over here. Can you see this average? And this is runs, and this is my average versus runs. Okay, so that's how you can plot. It is, the whole thing is only one single plot, guys. Okay, the whole thing is only one single plot. Okay, now when I see, let me run this actually. So if I run this, what I'm going to get? Okay, I got this. Now if you want to save it, I will be using figure dot I would say save, or what is it? Save fig. Okay, see, I was able to save. So even though these are separate plots, okay, but in the figure, this fig parameter, what you got, right? So that is for the overall figure. Okay, now I think you are able to understand. Using the subplots, square dot subplots, it will give two things. One is figure and Ax. Okay, now figure is for the overall image. Ax is for the axis, that means individual images. Okay, while plotting, you will use Ax indexes. Okay, but for this, finally for saving, you will access it by the figure. Clear, guys?
Yes, sir. Clear. Sir, what is ShareX?
ShareX, yeah, good question. Because see, I'm telling you, there will be so many parameters in the in any given function, Meghna. So it's not that we will use all of those, but since you asked it right, so let me also check it. Okay, so ShareX, but you will definitely find it. Okay, some will by default. Okay, for example, Matplotlib scatter plot. Okay, what was the scatter plot or subplot? Subplots. Okay, subplot ShareX. Okay, Matplotlib subplot ShareX. Oh, I think is it it is showing in the x-axis in the x parameter. Okay, we'll experiment, don't worry. Okay, so if I do it in the false, what we are going to get? Do you see any difference? I don't see any difference. Okay, so we'll see. ShareX over here. Now what is the ShareX? Control, okay, controls sharing of properties among x or y axis. If it is true or all, x or y will be shared among all the plots. Okay, false or none, each subplot or x-axis will be independent. Oh, okay, each row subplot will be shared. Okay, so I think it is saying that the x-axis and y-axis, whatever you are using, right, so that will be shared by the all the graphs. Okay, so I mean I see, so here you're using ShareX, right? So ShareX, when I do over here, so what I understood from here is when I do ShareX equal true, that means x-axis or whatever you're using y-axis will be shared among the all the plots. If you don't want to share the axis, that means the values are different for different plots, then you don't need to share. Okay, but for example here I'm saying ShareX equal to true. Okay, so where did it go? Okay, so see what happened is, yeah, I see a difference now. See, when I did ShareX equal to true, it has used the same x-axis for both the plots. It did not use the x-axis values over here. It is using only one value, and these are only applied to this also. Okay, just observe this, there are no values over here for the above red graph. But if I do false, why? Because I'm saying share x equal to true. That means share the values of x between all the plots. So it is sharing the same this 0, 10 values, x-axis values for both the plots. But if I say false, okay, if I say false, it is not sharing. So if we don't share, what will happen? Each plot should have its own values. So that's why it is having, this plot is having its own values, and this plot it's having its own values. Are you able to understand the difference?
Yes, sir.
Okay, so simple. So that's what I'm saying. There might be many parameters. Okay, so even in future, if you are by default, most of them will be taking by default values. Okay, just in case if you find something new, a single Google search should definitely help you, because in the original documentation, right, so everything will be documented. Okay, the official documentation. So yeah, that's a good learning for me also. So ShareX, ShareY, but the reason why we have used it as a true is because for both the plots we are using the same x-axis column. Here also it's battery average, here also it's battery average. The x-axis is same for both the graphs. That's why we can directly go for the ShareX equal to true. Agree? Fine. So, but what will happen? See, but the y-axis is different. So here the y-axis is 0 to 6,000. Here 0 to 200. Okay, but just as experiment, if I use share y equal to true, what happened? Let's see. Yeah, see, it's doing, but here it's not helpful. Fine, so it is using the same value for both. Yeah, so here it is using the same value, but obviously this will be this, here we will lose the sense. Okay, so let's not use that. Okay, let's use ShareX. Okay, fine. So that's about the thing. Okay, but what did we study? Yeah, the main takeaway should be this: how you can use the AX. Okay, we are also going to see much more easier way how to plot the subplots, but the first thing, the basic when you're learning, right? So if you want to create subplots, just create in X number of rows, number of columns, and plot this. Okay, now this can be extended. So when I'm saying one thing, right, so just try to extend that. Okay, in the sense, like instead of using number of rows 2 and 1, so you can also create more. Okay, and also instead of using only scatter plot, you can also go for line plot. Okay, for example, see, this graph is different and now this graph is different, so both are independent of each other. You can do anything with this, you can do anything with this. Okay, there is no rule that you should use only scatter in both them. I will use line graph. Axis not having line. What does I can use? Do I have axis dot simple plot? Do I have? Yeah. Okay, so if you see, in first graph I'm using scatter plot, and second graph I'm using just sort of line graph. Okay, so you can do anything. So both these are independent of each other. We are just using same common graph to plot two different graphs. Okay, that's all. You can do anything you want to do with this and with this. Okay, and also, as I said, if you want more graphs, okay, if you want see how many columns we have, guys. You have how many columns we have? Average, strike rate, and runs. Agree? So average and strike rate is done, and average and runs is done. We'll also do strike rate and runs. Okay, so we'll also do strike rate and runs. Okay, so that means what? Strike rate and runs means let's have it at one more column. So one more column in the sense what? I want 3 rows. Okay, I want 3 rows and 1 column. Okay, so over here I'm doing this. Okay, now what is left? I am plotting strike rate. Okay, and I'll go with some green color. Cool. Fine. So once I do that, yeah, I'll also quickly add something. Okay, so this will be 0, 1, and this will be for 2. Okay, and this is for 2, this is for 2, and this is for strike rate and runs. Okay, and y label will be my runs. Okay, done. Now when I run this, see, you're able to see. So the figure size is bit small because we are plotting all 3 into 1. Okay, so let me increase this to some 15 and some 8, and let's see. Okay, the problem here, if you observe, what the graphs are a bit different. Okay, why? Because if you see, I am using share x equal to true, the parameter which we have seen, Megan. But here earlier we are using only these 2 graphs where the x-axis is same. Both are average and average. That's why it worked. But now I'm using one more column called as this. Sorry, one more graph. But here the x-axis is different, strike rate. But still, when I set share x equal to true, it is trying to use the same x-axis. That's why these graphs are little bit compressed. You're seeing? You are understanding?
Yes, sir, understand.
Yeah. So in this case, I want it as false. Okay, and also I'm increasing the figure size. Now if I run this, so each of them will have its own graph. Okay, so yeah, this is better. Okay, so it is having its own x-axis and y-axis. Okay, and it's having its own x-axis, it's having its own x-axis. Okay, fine. So but still there is some overlapping, right? So you can still go for a little bigger size. Okay, so for example, I'll go for 20 and 10. Okay, fine. So it's, you can also control the size of each individual this plot also. We will see it in a while. Okay, but fine. So this is how you can draw. And also, if you observe, we are also saving it, the figure parameter, right? So using that, we are saving the plot. Fine. So if you go over here and what was the name I used? Subplots.png. Okay, so when I see here, see 3 graphs got successfully saved, and this is in the PNG format. You can save and send it across. Okay, and store it somewhere. Okay, fine. So that's the basic subplots. I hope that's clear and interesting. Okay, Now going to second step. Okay, now see here, the same thing, the basics is same. Once you understand these basics, right, so it's just play around between these parameters, guys, nothing else. Okay, the once if you understand how to create the subplots just by using pld.subplots and using number of rows, number of columns, and share x and figure size, right, and you understand you get two parameters out of it, figure and ax. Using figure is you just save it, the overall figure, the complete figure, but mostly with the ax you can access the individual graphs and assign some values. If you understand this, it's just extension of that, nothing else. Okay, see, now we are going to see, instead of having only one column, that means it is all only in all different rows the graphs are plotted. You can also change it. See here we are having 4 columns. Okay, so just as I said, right, you can use it like for sepal length, sepal width, petal length, petal width, like 4 different combinations. You can use these 4 graphs. Okay, so how we are going to achieve this? Just it's like an Excel sheet, right? So 2 rows, 2 columns. So you should get an idea that you need to use 2 rows, 2 columns. Okay, and once you do that, how to access this, that's different, that's important. Okay, so now once I do this, right, so you're having first graph, second graph, third graph, fourth graph. Okay, the first graph is simple, it is 0, 0. Okay, so this is 0, 0. Okay, this graph is 0, 1. Okay, and this graph is, okay, so let me put it over here, 0, 0, 0, 1, 1, 0, 1, 1. Simple indexing. 0th row, this is 0th row, first row, 0th column, first column. Okay, using this you will get the indexes. Okay, where you are going to use the indexes? In the ax. Okay, now ax of 0, 0, that means this graph you are plotting the scatter plot and the color is red. Okay, so if you're getting, if for a better differentiation, let me use different colors. Okay, so here I'll go with orange. Okay, and here I'll go with pink, and one I will leave it for the by default color. Okay, see, red, green, pink, and default blue. Okay, so this is what 0, 0. This is 0, 1 means this 1, 0 is for pink color, this one, and the by default last one 1, 1 is for the histogram. Okay, and 4 different graphs we are able to plot. See, okay, so can I do bar plot with this? Okay, bar, okay, you are having 2 things. Okay, so let me use plot. Yeah, see, 4 different graphs. It's not making sense, but just the graphs. Okay, and second, the other thing what we have understood over here is what did we learn? 4 different graphs you can use, and these are the, yeah, mainly how you can access. So is the indexing of this ax clear, guys? This particular part?
Yeah, Santosh, that is clear. But what is the use of plotting only one average and only running a graph?
No. See, that's what I'm saying. Don't care about what we are plotting now. Just focus on
Okay.
how we are plotting.
Okay. That's
So
clear.
this
That's
is
clear.
just I'm showing you how you can plot, but
Okay.
I'm not going into like, see, what is the point of plotting this one? This is not making any sense. That's what I'm saying. Just ignore the kind of plot what I'm plotting. Just understand like how we are plotting. So once you understand how we are plotting, you can use it for the other plots. Like you can take ID set or something. So instead of using, just now you said, right, what is the point of plotting only one graph? So you can use this, once you understand how to plot, you can use this to plot only petal length. Using only one single length, only one column, you can plot and you can understand what is the maximum value, minimum value, and whether any outliers or some fluctuation, something you can understand, right? So learn the concept, how we are doing. This is just how. Okay, where you want to do, that depends on use case, where you depends on data set. Okay,
Yeah.
fine. So this indexing part clear, everyone? Okay, I hope that's clear. So same thing, you can extend this to any number of plots also. Okay, and you can access in similar way. Okay, if you use more number of columns, so this will be accordingly. Okay, Fine. So I'll be extending the class a bit, guys. Okay, because there's a simple graphs. Okay, I don't want to take more classes for the graphs. Okay, because once we complete the graphs, right, so we can start with the feature engineering. Okay, feature engineering, there will be like a lot of new things. Okay, there I will go a bit slowly if required. Okay, but graphs, I think it's very simple to understand, so we can extend a bit. What do you say, guys? Is it fine?
Yes, sir.
Okay. Fine. Or else, if it is getting too lengthy, let me see. What do we have? So we have these plots and scatter plots we have, and okay. Let me see. We have how many days? We have 2 more days. Right. Fine. I would say we'll cover only one concept because too much of something will not serve the purpose. Fine. So I'll just cover 1 or 2 concepts, and don't worry, we'll cover the remaining in tomorrow's class. And Seaborn we will be covering in. I'll start Seaborn tomorrow, but we'll conclude it on the Saturday part, so that as discussed, we can successfully complete the visualization in this week. Okay, and next week we can freshly start the feature engineering. Okay, fine. So just to go back, right? So we understood the subplots. Okay, and the better way. Okay, the better way of doing the subplots is not this way. Okay, this is also one way, but this is also actually good. But usually how we can directly do here is, see, plt dot figure. Okay, that is fig. Okay, now what we are going to do here is, directly when I say to this figure, okay, first we have created the figure. How did we create the figure? From plt. Plt is what? Matplotlib. From plt.figure, I have created fig. Using this, to this figure, I'm adding. Okay, so I'm just adding the required subplots. Okay, if I want only one subplot, I will add only one. Okay, based upon my requirement, I'm just adding. Okay, so first I'm adding figure.add plot. Okay, 2 comma 2 comma 1 means what? 2 rows, 2 columns. Okay, total of subplots is, in the total of subplots, I'm dividing it into 2 by 2. That means 2 rows, 2 columns. Okay, and dividing into 2. In that, I'm taking the first one. Okay, so this is first one, this is second one, this is third one, this is fourth one. Why? Because I'm saying 2 by 2 by 1. Okay, understand this, guys. 2 comma 2 comma 1 over here means this 2 will tell you the graph size. Okay, that means 2 rows, 2 columns. That means 2 rows, 2 columns, in the sense 4 graphs are created. Same like this. I will take this example. Okay, here also what we did, I said 2 rows, 2 columns. When I said 2 rows, 2 columns, how many graphs I got? 4 graphs. Okay, so similarly, I'm saying 2 by 2. So this 2 comma 2 means 2 by 2 means 2 rows, 2 columns, 4 graphs I got. In that 4 graphs, I am taking the first graph. This will be 1, this will be 2, this will be 3, this will be 4. Okay, just like here. Okay, this will be read 1, 2, 3, 4. Okay, in similar fashion, I'm doing it in a different fashion. Okay, so I'm taking the first one, that is ax1. I'm creating it as ax1. Okay, did you understand this step? Tell me.
Yeah, Santosh.
Okay, so now to this ax1, now this ax1 is what we are doing. This name, whatever, you can do anything. Okay, but I have given ax1. To this ax1, you can do anything. Okay, so that just a small difference you can observe here is, see, both things you can do, but here directly I am specifying the number of rows and number of columns over here to the figure and ax. Okay, and using this, the same ax, I am using the indexes, I am plotting. Okay, using the indexes, I am plotting every time. But here I'm just first of all, I'm using the index itself. I'm creating a variable, and using that variable, I am just plotting. Again, I don't need to give the index. Okay, there's a small difference if you observe. Okay, so using the figure, I've just plotted the figure. I'm saying 2 comma 2. In 2 comma 2, the first one I'm taking. Okay, that is ax1. Using ax1, I'm just plotting scatter. These things you are familiar now. Okay, that's fine. So if you see in the 2 comma 2 comma 1, that means this one, 2 rows, 2 columns graph. In that, I am just using the first graph. Okay, that means only this one. Okay, only this one. Fine. So if I just run this, for example, okay, so I got this right. So for example, if I see, I got only one. Okay, but next 3 graphs are available. Okay, plot 2, plot 3, plot 4 are available because this is from a 2 comma 2. 2 rows, 2 columns graph. I'm using only first one. Okay, that is how it is done. Now after that, if I use this also, okay, so here 2 comma 2, I'm using the second graph. Okay, I'm using second graph. How I'm doing? Same. I'm just adding this graph to first this my figure to the figure I'm adding. Okay, because figure is overall figure. You agree, right? Because when I save it, the overall figure, how I'm getting this, because I am saving it to the overall figure. If you observe here, yeah. So if you observe, even though we are creating 3 different graphs, the overall everything will be inside this single FIG figure. Okay. So now to do that, so here in this earlier approach, directly we are creating using this. Okay, you don't need to add separately, but here you are individually creating, right? So that's why you need to add. First of all, you should make every single plot a part of this figure. So that's why I'm adding this 2 comma 2 comma 2 this figure. Okay, once you do that, you will get this ax2, and using ax2, I'm just using the histogram plot for this runs. Okay, so and for the third one, similarly, I am using 2 comma 2 comma 3. Okay, this is 3, and I'm just adding to ax3, and this is the plot. Okay, and this you can also do it for 4, but I don't want. That's my wish. Okay, so but one more thing is available. This will be 2 comma 2 comma 4 is this. Okay, if you want, I will add. If I don't want, I will not add. Okay, it depends on me. Clear? But here there is a difference. If you see here in the earlier example, when you are creating, when you are directly creating this is earlier example, guys. Okay, so I'm just showing you the difference. In the earlier example, when you do plt.subplots, and when you said number of rows equal to 2, number of columns equal to 2, okay, that means 4 graphs are already created. Okay, 4 graphs are already created. How? Because you see this, now you'll understand. Okay, now I'm just saying this, I'm not plotting anything at all. Okay, I'm not plotting anything at all. I'm just saying I want from Matplotlib, I want to create 2 rows, 2 columns, that means 4 graphs with the size of this. Okay, and then this is a figure and ax. Okay, when I just run this, I got 4 graphs. See, are you able to understand the difference? The graphs are already created. To each of this graph, I am plotting all these values. Okay, but over here, the graphs are not created in advance. You are according to your requirement, you are just adding each graph to the figure and then plotting. Okay, so if I don't do, if I plot only one graph, it will show only one graph. Okay, so if I plot only 2 graphs, it will show only 2 graphs. Okay, so it will not show this unnecessary boxes over here. Okay, in some cases that might be helpful. In some cases it might be helpful, showing that you have also one more box available, one more graph available. Okay, so it depends upon your purpose. If you want to use that, you can, or you can use this. Okay, but try to understand the difference. Okay, over here, whatever the graphs you are using, only those will be created, and it will just say empty over here. But here, if you just plot only 3, if you plot only 3, okay, for example, I will remove this. Okay, so see here, one box, it is empty. It is saying you have created, it is saying you have created 4 graphs, because you said number of rows equal to number of columns equal to 2, but you have plotted only 3 graphs. You do not go for the 4th plot. Is it clear, guys? Did you guys?
Yeah, Sam.
Okay, cool. One thing I want to try now is whether we can change the figure size of each of these graph. Okay, I just want to experiment with that. Individually it's not helping. Okay, so but over here, if I do this, okay, inside that it is not available. Okay, fine, don't worry, I'll check it. So if you want to change the size of each this box, usually it's not recommended, but just I want to see whether we can change the size of each individual block also. Okay, fine. So but I hope these two graph approaches are clear to you, right? Both subplots, first thing is basic subplots. Second thing is, see, this is a basic subplot, okay, which you have seen. Second thing is how you can create multiple subplots by default. And second, the last thing is how you can add as per your requirement one by one. Okay. So I hope that is clear with you. Okay. And AX is for the indexes. Okay. Here you don't need to use index because you're already adding. Figure is for the overall figure. Okay. And here also you can actually save it with the overall figure. So now when I do this, okay, so this figure, if I want to save it, so I'll just, here I will say subplot using the index. Okay. So let me see subplots using the index is this. Okay. Beautiful graphs I got. And over here I will say subplots with the adding plots. Okay. So now if I say, now I got subplots adding. Okay, cool. This is directly you're using the index. This is adding step by step. Are we good, guys?
Yes, Santosh.
Cool. And this is just to show you the AX part. So when you just do this, it will just create the number of boxes just now, which we have seen. Okay, fine. So after that we have just something called 3D scatter plots, which we don't usually use, but just in the Matplotlib which we have, it's a 3D projection, guys. Okay, so based upon see batters, if you want to plot all three in one particular graph itself, so batsman average strike rate, so see runs average, and this y-axis will be, see this one, x-axis, y-axis, and this is z-axis. This is strike rate, yes, you are seeing here, right? So on 3 axis it is able to plot, and these are the projections. Okay, this is a projection, so it will take bit difficult to comprehend and understand. Okay, but better to go for 2D graphs. Okay, but just there is also feasibility. If you are interested, you can see it will take x-axis, runs will be plotted on the over here. Okay, some y-axis and in the z-axis. Okay, this is a 3D graph. Okay, not generally used. I'm not seen using 3D graphs. Okay, but one more option in the scatter plots. Fine. So next we have heat map. Okay, so this we are going to see it tomorrow. Okay, so tomorrow I don't want to stretch too much. Okay, so tomorrow we are going to see a few interesting graphs. I would say just to give you an overview. We are going to see heat maps, and heat maps are very important. It will also be helpful in your correlation graphs. Okay, and same pie plot which you have plotted, so we will see it in different way how you can plot, and there are some line graphs. Okay, so okay, a few concepts which we'll see tomorrow. Okay, but let's quickly step back and have understand what we studied today. So we have seen the scatter plot. Okay, we have seen the color coding, we have seen the color mapping, alpha part we understood. Okay, I would suggest you to experiment with the iris data sets. Okay, so please do that. And after that we have seen plot set figure size. Okay, figure size is very important. Okay, and after that we have seen, yeah, this one very useful, how to attach the text also to the given bubbles, how to determine the size of the bubbles, agree? And next thing is how to just add horizontal and vertical lines, cool. And how to create a subplots over here, yeah, how to create a subplots, okay. And ShareX also a new thing which we have seen, and figure size, fine. And then we have seen how to by default create all the graphs and then add the plots, or just start adding each according to your requirement, okay. And last thing we have seen a simple 3D plot. Yeah, I think it was good. We started something new. So are we good, guys? Is this interesting? Are you guys enjoying the session?
Yes.
Okay, cool. So as discussed, tomorrow we'll try to conclude this, and then we'll also start with the Seaborn. And Seaborn will be interesting, guys, because in Seaborn, even though this is good, but still these are basic, okay. But I'm saying Seaborn, we have so many options in practical purpose, right? So Seaborn, we'll use mostly Seaborn, and it has all different types of graphs. Mostly from this, all the statistic functions which you have seen, right? The KD plot, probability distributions, correlation graphs, everything is possible. Pair plot, we have violin plot, bar plot, box plot, okay, many plots, okay. All those are possible in Seaborn library, okay. So with those, we are going to see like some top 10 Seaborn graphs we are going to see, and also different functions, basic functions from Seaborn, okay. That will be much more interesting. This is also interesting, I would say. Graphs are very interesting, guys, I would say. And it's also, once you understand the graphing, right, so it will make you life bit more easier in data science, I would say, okay. Because just I'll tell you, see, as I told you, just to understand what you're understanding from this graph, you can also do it from the Excel sheet also, but it will be difficult, okay. Once you plot this, right, we can understand many things, okay. So this guy is playing very well, but his average is very high. So see, this guy's strike rate, okay, this is average, okay. So just you can see K Pollard strike rate is very high, but average is not that great, but he has scored very great runs, okay. So the Jayasuriya runs are very less, but his strike rate is okay, decent, okay. And then his average is less, okay. So based upon, for example, how you can use this, okay, based upon particular match, okay, the selection team can decide, okay. For example, it's just a IPL match, okay, where you want the strike rate should be high. That means he don't need to stay long in the field, but he even if he stay for less amount of time, okay, shorter, but he should score much, okay. That's called strike rate. For example, we have Suryakumar Yadav, right? His strike rate is very high, but he doesn't score much runs, okay, but his strike rate is high. That means what? In very less number of balls, he can score greatly, okay. So in using this graph, okay, you can pick wherever the strike rate is high. So all these persons, okay, so just if I show you all these persons whose strike rate is very high, that means you can just put a see, that's why we are using this 130, okay. Just say 130 is a benchmark. All the batters whose strike rate is greater than 130, you can select these guys for the IPL, just as an example, okay. But for in some cases, let's say in World Cup, okay, World Cup match, I don't want strike rate, I want him to stay in the field as long as possible. So where I want the average should be great, okay, average, at least he should make this many runs, okay. So there I will put a cap of, let's say, 37.5, okay. So 37.5 is my average, okay, only greater than 37.5, okay. These three members I will select him from the World Cup match, okay, where the average is high, okay. Luckily strike rate is also high, that's a different matter, but average is high, okay. And in some other particular match, I want to see who has scored the maximum runs, okay, this guy or this guy, okay. Those simple insights you can derive directly from this graph, okay, as an example, okay. So that's why if you understand graphs, it will be really interesting, okay. Fine, that's all from my end today, okay. Thanks for joining. Let's meet tomorrow and complete the Matplotlib remaining concepts, okay. Fine, guys, thanks so much. Bye.